5.1. 5.1, number 4. All right, so I was working on number 4 with somebody either before school or during tutorial or something. Number 4 is literally the exact same problem as number 5, but without numbers. All right? And the fact that we didn't have 5 on the list up here leads me to believe they've already got 5 correct. Yes?
Yeah.
No? Does anybody need me to do 5? Because I want you have to understand 5 to understand 4. Do you need me to do that?
I got 5A.
B should have been the same as A, except you just put the force coming from the other side.
Oh, maybe I'm just like...
Yeah, double check your math. It's the exact same process as A. Okay, so here's the deal then. So for 4, you've got these two blocks. You've got a block that's got a mass of capital M and a little block that's got a mass of little m. Okay? And we're going to push this whole thing with a force of F. And the question says, what's the magnitude of either of these forces, either of these blocks on the other? So we're looking for either the force of big block on little block or the force of little block on big block. I think I said those backwards, but you know what I mean. Good? Now, there are 3 free body diagrams you should make. Okay, there's the free body diagram for the 2-block system, and then the free body diagram for the individual blocks. So, if I do both blocks, guys in back, please. If I do both blocks, the only force I need to worry about is the F, right? Good? If I do just the big block, then there are 2 forces on it. There's F, and then what else, you guys? The force on the big block by the little block, right?
Yes.
Follow? And if I do just the little block, what's the only force on the little block, you guys? The force on the little block by the big block, right? Okay, and what we're trying to find is one of these 2 FMMs, right? Everybody good? All right. So neither of these 2 drawings look very helpful to me because in these 2 drawings, there are 2 unknowns. Okay? In this drawing and this drawing, I don't know, there's a missing force in each of them, and I don't know the acceleration. So there's literally no way for me to deal with net force or acceleration in those problems. So I've got a missing force and a missing acceleration. Follow? So which drawing do I want to look at? The system, right? So if I look at this top drawing, I can discover that the acceleration of the system is F over the mass of that system. Good? So, what does that mean the acceleration of the 2 other blocks is? Same thing, right? Oh. So I ought to be able to find the net force on each of these 2 things, right? So for this one, my net force is going to be capital M times that, right? Right, because this is my acceleration, MA. Okay? And on the bottom one, oh, darn it, I need like... On the bottom one, my net force is little m times F over m plus m, right? So, thoughts now? We're trying to find the force on block M by block M. So we've got to find one of the 2 FMMs. Talk to me about net force, you guys. What do we know in these 2 bottom drawings? One of the 2 drawings is more helpful than the other one. Okay, so Evan, I hear you talking about this one?
Yeah.
So you're saying the F minus this has to equal this green blob over here, right?
Yeah.
So that works, but I hear somebody in the back, Sarah, I think you said?
Well, the bottom one just has 1.
The bottom one, you don't even need to worry about F, right? So on the bottom one, Isn't my net force FMM? Oh, we're done. This equals FMM. There's your answer. What's wrong? Oh. Seba, where did I lose you there?
At the end.
So, in words, describe to me the net force on this thing.
Just F and F.
Okay? And we also know net force equals net force, right? So this is NA,
Okay.
and the net force is FMM. And the question wanted us to find FMM.
Oh, it's
Right? Because the problem said, find the force that one of the blocks exerts on the other blocks. So that's FMM.
okay.
Sarah?
Why couldn't you do the green one?
You could, but the algebra gets ugly. So if you do the green one, here's what you get. So it's, all of this, you guys, is still just net force equals net force. So what Evan said was, my net force is MA, so that's capital M times F over M plus M, right? Equals F minus FMM, right? So let's see, so to solve this thing, we'd have to do some algebra. So I'm going to add FMM and then subtract. So you get FMM equals F minus this mess, right?
Okay.
Good?
Yeah.
So let's finish it. We're almost done. So this becomes, what do I got to do? I've got fractions. What do I need to do? Oh, hey, Maggie, remind me to change our attendance. Common denominator, right? So I'm going to get F times M plus M minus MF all over M plus M. And the MFs cancel, tee-hee, and you're left with FM. Sarah, you good?